My name is Piotr Soczowka, and on behalf of myself and my co-authors, I would like to express our gratitude for the possibility to present the results of our research via the internet. The online conference is obviously not the ideal arrangement, but hopefully all of us will still be able to benefit from this experience even without the possibility of meeting face to face. Oh, too far. Okay. The topic of our paper is the analysis of traffic safety on the intersections of roadways and tram tracks. The paper was prepared with Professor Renata Soczowka and Dr. Marcin Jacek Kłos. A few words about the research problem. Nowadays, modern urban and metropolitan areas have to cope with different problems that are associated with the negative side of transport activity, such as pollution, noise, congestion, or traffic incidents. To reduce the negative impact of transport on the quality of life in large metropolitan areas, different tools of sustainable mobility are exploited. Among trends associated with sustainable mobility, one may enumerate the growth of the significance of public transport and the increase of the number of trips made using means of public transport. Now, in order to encourage people to choose it, it is indispensable to provide an efficient, reliable, and safe system of public transport. Tram communication may be an effective solution, as trams are eco-friendly and able to transport a large number of passengers at a given time. However, bearing in mind the number of people that may travel by tram and potential disruptions in the tram network, any incident involving trams should be treated as hazardous and potentially leading to serious consequences. Therefore, it is essential to identify hazardous road locations in the tram network and analyze them in order to reduce the level of risk. There is a variety of approaches to performing such analysis, and the main objective of our research was therefore to propose a spatial temporal approach to such analysis of incidents. Our research was focused on incidents occurring on the intersections of roadways and tram tracks. The spatial temporal approach provides a comprehensive view on the issue and allows to identify factors that have the greatest influence on such intersections. Subsequently, it allows to determine necessary actions that could reduce the level of risk in particular locations. The figure on the slide presents the general scheme of the methodology. The developed method assumes the use of available databases of the incidents and topography for the analyzed area. The data about incidents should be historical, encompassing at least previous 5 years. Data about the topography should allow to visualize roadways, tram tracks, and intersections. Because the analysis encompasses 2 areas, spatial and temporal, it should be done based on the 2 described databases with the necessary data preparation. Data about the incidents should allow to obtain all necessary descriptions of the individual incidents, and it is necessary to have all incidents described in the same way in order to compare them. The next figure presents step-by-step spatial temporal analysis of incidents on the intersections of tram tracks and roadways. It should be conducted both for the entire analyzed area and for each identified hazardous location. In case of the analysis for the entire area of study, during the spatial analysis, each location where incidents took place should be identified. Subsequently, it is possible to perform the analysis for chosen territorial units or to narrow it down to particular types of intersections, for example. Next, when analyzing chosen hazardous locations, one can concentrate on users' mistakes, traffic organization, infrastructure, or other particular spatial aspects. The temporal analysis for both the entire area and each hazardous location should be focused mainly on the variability of the number of incidents, and all this analysis should lead to the identification of solutions for the improvement of safety for each location. The proposed scheme of the analysis has been exploited in the area of Metropolis GZM. It is a large metropolitan area in southern Poland with one of the largest tram networks. The total length of tram tracks exceeds 350 kilometers. The network goes through 13 cities, and there are over 300 tram stops currently in operation. The table on the slide shows the total number of incidents involving trams and road vehicles for 5 years from 2015 to 2019 in each of previously mentioned 13 cities with tram tracks in Metropolis. Obviously, the total number of incidents in each city is associated with the length of tram tracks. Now, during the temporal analysis for the entire area of study, we focused on the variability of the number of incidents. Among the analysis that we performed, there was the analysis of the variability of the number of incidents in subsequent hours of the day. And according to the figure on the left, most incidents occurred during the peak hours. We also performed the analysis of the variability, for example, in subsequent months. In the spatial analysis for the entire area, we began with the identification of all the incidents on the tram network in Metropolis GZM, and all those locations when incidents occurred are presented on the first map. Next, we selected only those that occurred on the intersections of roadway and tram tracks, and this is shown on the second map. And last map shows the total number of incidents on each identified intersection. The proposed approach assumes that the hazardous locations might be chosen using numerous criteria. Therefore, in order to present the practical exploitation of the analysis for hazardous locations, we decided to choose a fairly simple criterion to select particular locations and only present the analysis, and it was the total number of incidents. On that basis, we selected 2 locations, both in the city of Świętochłowice. Location A is an intersection with only traffic signs, whereas in location B, there are also traffic lights deployed. Both locations are actually in close vicinity in the northeastern part of the city, as presented on the map. The aim of the spatial analysis for each location was to analyze the directions of each vehicle in each incident in order to learn about users' mistakes. In case of both locations, the highest risk is associated with the left turn made by road vehicles, which requires crossing of the tram tracks. As presented in the figures on the slide, vehicle 1 gives way to vehicle 2 and to tram as well. Hence, the drivers have to pay attention to traffic both in front of them and behind them. If the traffic intensity is high, then drivers focus mainly on finding the acceptable gap in the stream of the oncoming traffic, and they usually forget that the tram may arrive during the period when they wait. Such a traffic organization favors the occurrence of incidents as it requires drivers who make the left turn to focus on other vehicles in front of them and behind them. Temporal analysis shows that most of incidents in location A occurred in autumn and early winter, when the lighting conditions are most demanding. However, a few incidents took place also in the summer, which suggests a more complex relation. In case of location, too far. Oh yeah, this is the table. In case of location B, the distribution of the number of incidents in each season is rather even. There was 1 incident in spring, 3 in summer, and 2 in autumn and winter. The analysis of the variability in subsequent hours, on the other hand, shows that most incidents in location A and B occurred in the period of the afternoon peak, so from 1 p.m. to 6 p.m. During this period, there is the largest traffic intensity, and in autumn and winter, the lighting conditions may be demanding and difficult. To conclude, the analysis of traffic incidents, also those happening on intersections of tram tracks and roadways, should be supported by various research methods and techniques that allow to identify the causes of incidents. We propose a scheme of such analysis that includes two aspects, temporal and spatial, which ensures a comprehensive view on the issue. We perform the analysis for the area of Metropolis GZM and two selected hazardous locations in the city of Świętochłowice. This is everything I want to talk about, so thank you for your attention.